consider each of the following compound sentences. All right, that word consider. They use that in textbooks a lot on exams and stuff like that. But what I've recently come to understand is that students see the word consider no matter what grade you're in. Even my adult students in the college. They see the word consider, and they honestly don't know what it means. I mean, they know what the word consider means, but they don't know what it means in this context. All right? So what they do is they look at it. Yeah, good looking expression there. All right. Also a good looking expression. Now what? Yeah, I've considered it. Yeah, you didn't really learn the rules to the game. Like, what does it mean to consider mathematically? It means to look for similarities, differences, and what impact those similarities and differences have on the situation. So I'm looking at now, this is me really considering it. I have this guy and this guy. What's the same? Well, the inequalities look exactly the same. What's different? One has an and, one has an or. I considered all that information prior to even looking at the question. So now I'm looking at the question and say, okay, well that's what they wanted me to consider, that's wonderful. I might have noticed something about the expression that was given that has nothing to do with the question, but it might be useful information anyway. Does changing the word from and to or change the solution set? All right, so we have to create number lines only because the question told us to, but on a test, if it just said, does changing the word change the solution set, that's an implied yes or no. Yeah, it does. No, it doesn't. Whatever. Justify would give you free reign to either explain your word in words, your thoughts in words. I got it out eventually, or go to like an algebraic approach. All right. So in this case, it's requiring us to do something kind of in the middle. So I'm going to create a number line. I'm going to pop on a -1 and a 1. Also, something I noticed over the years is that, you know, like when I go off on these little, I'll call them speeches, I guess, where I'm like I'm giving you words of wisdom, words to the wise, things like that, nuggets, pearls, whatever you want to call it. So some people are like, okay, he's talking, he's talking, he's talking, he's talking, he's talking. All right, all right, all right. Oh, now he's doing something. Let me write that down. Right? And so in those cases, you may never truly understand why we're writing something down. So try to stay with me the whole time, no matter how boring I might sound. Anyway, less than 1. Oh, less than 1, not -1. Greater than -1. So if I look at the two sets independently of one another, that's what I'd be looking at there. Well, the word and is telling me that I have to satisfy both sets at the same time. So here's my at the same time. All right, so in the and situation, I would only be looking at values that are from -1 to 1. So I would say something like this, which translates to this. All right. So, funny, maybe you won't find it funny. I found it funny, and I gave the student credit too. So, on the test, the student wrote this as an answer. -1 to 1, -1 to 1. Except the only difference is the student did one part of it incorrectly. They had brackets on the -1 here and the +1. They got their parentheses and their brackets confused. All right. So I didn't say to put the answer in any particular form, but I took off half a point because that was incorrect. You know what the student said to me? You want to take a guess? Are you freaking kidding me? Of course, that was part of it. But then when the student considered their work, they came up to me and said, No, I actually deserve full credit on this one. They didn't say it that way. They were trying to like be super nice about it, because whether you're right or wrong, it really doesn't matter. If you come up to a teacher with an attitude saying, "Give me that point back," the teacher will find every possible way to not give you that point back, and then also find ways to take other points away that you hadn't had taken away initially. That's like numero uno. You don't want to do that. Right, so the student was very nice. Said, "You know what? I was thinking about this question, and even though I got this part of it wrong, I still think that the final answer is correct. So what do you think about that? Can you take another look at it?" And I did, and I realized that they were right. So I gave the half point back. Do you know why I did that? This would demonstrate incredible knowledge and understanding of this unit. Or. All right, so the student wrote -1 less than x less than 1, or -1 to 1. This part was true.
Only one of them has to be true.
Only one of them has to be true. This part was true, this part was false. But the rule of OR tells us so, using logical reasoning, the student demonstrated that their answer deserved full credit. Now, that's different from do all this work and write your answer in interval notation. So then in that case, I'm only looking for the interval notation, and if that's wrong, you're out of luck. But I didn't give any directions whatsoever in terms of inequality versus interval notation. The student came back and said, "Yeah, I know that was wrong, but it didn't have to be right. All I needed was one part of it to be right." And I was like, you actually met the standards of this unit. You understand exactly what's going on. So even if I was not inclined to give the half point back for the technicality, I would give the half point back just for true understanding. Right? So that was a pretty awesome moment. And you know, maybe it'll happen. So that's the true thing about it. Right? So if I were to say something like x equals 2 or 3, and 2 and 3 end up being the right answers, I could say 2 or 3 or apples. The apples part is irrelevant, it's wrong, but it doesn't have to be right, because all I need is one part to be true in order to be correct. Right? So that is pretty awesome. So that's the and. Now, or. Let's go with purple. For those keeping score at home. So we're going to have or. Now, or means that I'm looking at either of the two pieces being correct. One piece is correct, the other piece is correct, or both are correct. All right, the bottom line is I'm accounting for everywhere this graph goes and everywhere this graph goes. All right, in this case, there is some overlap, but it's irrelevant. It still satisfies the inequality. But this one goes forever to the left, so towards negative infinity. And it goes forever to the right towards positive infinity. So then ask yourself, am I missing anything? So if I look at my two number lines, my two arrow diagrams, and have I skipped over any values along the number line? Is there any value on that number line that has been skipped, yes or no? No. All right? And so whenever we're using the entire number line, we would say negative infinity to infinity in interval notation. I mean, you could also use the all real number symbol. Oh, I wanted to erase that or because it looked too thick now, but you know, the double R. But I think this is a better way to go, because sometimes you deal with situations where maybe you're not looking at the real number system. Maybe you're looking at a complex number system, but you still want to account for all possibilities. All right. So anyway, now we're going to solve equations in compound form. All right, so we've done it with, you know, a piece at a time, but all in one shot. Oh, you know what? This is the one thing I wanted to change because I don't like it. Nobody would ever do it this way. I'm sure, actually, that's not true. Somebody would do it this way because I got it from a textbook at some point, or online resource, or the state of New York, and somebody did it. It's just not the best way to go. The intuitive way to go is more understandable. All right. So let's make it solve the inequality for x. So it's a little funky. It's definitely an and situation because a compound inequality that's written in this form follows and, meaning the idea of being between two numbers. So that's what we're looking for here. An inequality, regardless of the form, works very much, and in fact, almost exactly like an equation, except you don't have to worry about the signs getting reversed if you divide by a negative. What I want to do is I want to solve for x. And I don't want to get x alone. So if I'm going to get x alone, I need to subtract a 1. All right, but if I subtract a 1 from that middle part, I'm going to subtract it everywhere. So that's the only way in which this differs from what we've been doing, is that we're going to do the subtraction in 3 places because there's 3 pieces. So we have negative 6 less than 2x less than 4. Then I would divide off the 2. If I divide off the 2 in the middle, that's cool, but I have to do it everywhere. The 2's would cancel. I'd have negative 3 is less than x, which in turn is less than 2. All right, you want to make sure your compound inequality makes sense. All right, because if you did have to reverse the signs, you'd have to pick up on that somewhere. All right, so just make sure that the size relationships are true. The arrows are pointing to the left, which means that whatever's on the left-hand side should be the smallest available. Whatever's on the right-hand side should be the largest available. So the smallest number is negative 3, the largest number is 2. Negative 3 is less than 2, so we're in good shape. What this is telling me is that I have a bunch of x values that exist between negative 3 and 2. So negative 3 and 2. So we have every possible, if you think about any number that could be x, as long as it fits in this interval, negative 3 to 2, what it's going to do is create a line connecting the negative 3 and the 2. Because whenever you're evaluating an inequality, you're looking for truth. So if I say negative 5, true or false, does that fit in that interval?
No.
False, right? So I would not put a point at negative 5. Negative 4, same deal. 3, same deal. 20, same deal. But if I take 0, 0 does fall in that interval. True, plot a point. 1 falls in that interval. True, plot a point. Negative 1, negative 2, same deal. A quarter, a half, 1.5, 1.99999 all give us true sentences here. So because that's the case, they all get points, and so we have all of those points on this interval telling us where the graph exists. All right. So it's a way that you can evaluate things, and it might help you understand it a little bit better. Almost spilled my entire cup of coffee. So just back to C, just to address it. Write a sentence describing the possible values of x, and then I give you the world's tiniest blank to write that sentence, so not really the world's, it's hyperbole. Okay, so all values between negative 3 and 2? All values between negative 3 and 2. All right. Number 2, solve each compound inequality for x and graph the solutions on a number line. All right, so this is an and situation. So we would like to be able to create a compound inequality like this, where it has that betweenness component. The issue is I have 2 different expressions here, x plus 6 and x minus 1. So we have to handle that first. We want consistency. Let's just do it this way first. So we solve each one, subtract the 6, subtract the 6, add the 1, add the 1. So this is kind of like what we were doing a couple of days ago. X less than 2 and x greater than 0.
Oh wait, so the upside down V means and?
Yes.
And then the regular V means or?
Correct. And what people have said in the past has helped them is that that's almost an A, and starts with an A. That's a Friday fun fact for you.
I don't understand what that means.
What the symbol means, or what the word and means in this situation?
Yeah.
The second thing I said?
Yeah.
Okay. So it's saying that I need numbers that are at the same time less than 2 and more than 0. At the same time, I need so an x value or a set of x values that would satisfy both parts. So I need numbers that are less than 2 while also being greater than 0. So give me a number.
4.
4 is not less than 2. 1. All right, so let's say x is equal to 1. This is what I was talking about with truth before. X equals 1. We would have a true statement here, right? True and true.
Yep.
The only way an and sentence can be true is if both parts are true. So true sentence. But if I have something like x equals 3, it doesn't satisfy the first one, false, but it does satisfy the second one. If this were an or, I'd have a true sentence here, but in this case I have false because both parts are not true. So on my number line, yeah, I have my relevant values 2 and 0, but I'll plot a few more. So like -1, 0, 1, 2, 3. So here are a couple of points. At x equals 1, I have a true sentence, so I plot a point above the 1. At 3, I have a false sentence, so I'm not plotting anything there. All right, so maybe I try something like x is equal to -1. -1. First part is true. Second part is false. False sentence. So I'm not plotting a point at -1. All right. But if I choose something like 1.5, I get a true sentence, right? So I plot a point. 1.999, true sentence, plot a point. 0.25, true sentence, plot a point, and so on. So you have all these points that exist on this interval. You can never hit the 0. You can never hit the 2. But that gives us our interval. All right, so just checking the truth of your sentence is often all you need in order to come up with the correct result. All right? And I'm a big fan of truth. It's a good way to look into things. So my solution in interval notation would look like, oh sorry, I put 2. And I put -1. I don't know, I just wrote numbers that I saw. That was so weird. There was nothing right about what I wrote there. 0 to 2, or if you want inequality notation, I don't know, it's definitely Friday. Depending on the situation, I could accept either of them. All right. Those are a little bit tougher to do because the and is not, I mean, even though the word and is written in front of you, the framework of the question doesn't tell you what you should do, all right? But in the second one, it does. All right, so you can see the relationship between the two expressions here. They're both and situations, but in this case, I think it's pretty clear what you should do first. You want to isolate x, or maybe that's not going to necessarily give you the first step, but it'll give you something. I don't know why I crossed those out. Because when they look like this, it's and. So when you have an and situation like this, our answer ends up being x in between two numbers. So and corresponds with this format of an answer. So anything that has that format would have to be an and situation. Or would not be framed that way. If you had something like this, you would never treat it like or, because this corresponds with and only. Yeah, and there's a good reason for that, because and is the one that's trickier. Or is pretty cut and dry, because you have two separate inequalities, you solve them, slap an or symbol in between your two answers, and call it a day. It's the and where you need some workaround. And that's where truth comes into play. Leave the board alone, please. Like, that's a forever rule. Thanks. So, yeah, evaluate the truth. Come up with numbers, see if they make sense in the situation, and then go from there. Here I'm dividing by a -2. Got to flip that inequality.
And you only flip it on
Multiplication, division, exactamundo. All right, now the good news is, if you really evaluate what you're looking at, instead of just like, well, here's my answer, I hope it's right, I'm moving on to the next question, I just want to get this homework done, you know, that kind of thing. If you actually think about what you wrote, it should make sense. If I had my inequalities facing the wrong way, I would be saying 2 is less than x, which is less than -7/2. Is 2 less than -7/2?
No.
No, it's a false statement. All right? So I would know that something had to change, and hopefully I'd figure out what it is. All right? But evaluating the truth. I mean, I'm really into truth.
Wait, but
I'm also a big fan of justice.
to the line thing, do we have to, do we change it to 3.5?
Yeah. Yeah, the only time you definitely want to stay in fraction form is if you have a messy decimal. All right, where it would be much cleaner to leave it in fraction form. But if it's a clean decimal, like 0.5, 0.25, things like that, it's perfectly fine. I also like, when I see this, to switch the order around. Just so I know what I'm doing on my number line, because I've seen people do this before. They get this inequality, they put the 2 on the left side of the number line, they put the -7/2 somewhere on the right, and they just connect them. Like, well, that would be great if math worked that way, but it doesn't, so. So, -4, -3, -2, 0, 1, 2. All right. The observation was that -7/2 is the same as -3/2. So that tells me on the low bound, I'm plotting a point with a closed circle because of the inequality, including an equal sign, above roughly -3.5, but I'll write -7/2. And then a closed circle above the 2, connect. All right, so we're looking at a few different varieties of question here. Some of them are clearly ands. Some of them are clearly ors. Some of them have a hidden or in there. Like, you have to look at it carefully, and you see that I have an expression here, an inequality here, and an equation there. And somehow those two ideas together are going to give me a solution. The easier case is the case like in part C here, where it's explicitly stated for you. Add the 9, 3x is less than 9, divide by 3, x is less than 3. Then shift gears and go over to the other one, add a 2. And so you get 10 less than or equal to x. I don't like it like that. I like it the other way. X would then be greater than or equal to 10. Slap an or sign in the middle. All right, so I need values that are either less than 3. So let me do that like this: 0, 3, 4, 5, 6, 7, 8, 9, 10. Less than 3, open circle on the 3, going to the left. More than or equal to 10, so closed circle on 10, going off to the right. All right, like I said, the ORs they're more procedural. It's solve this one, solve that one, and be done with it.
Oh, why'd you flip the sign?
Because I always want, me personally, I always want x on the left. So if 10 is less than or equal to x, that means that x has to be the larger value, so x must be more than or equal to 10. That's this idea. Right?
Do
So,
you have to flip it?
I suppose you don't have to, but doing it leads to a truer. I didn't finish my sentence. You know, you're going to agree with it. Doing it will allow you to understand it better. Right? That's when you say okay. Right? So 1 less than or equal to x. If you just kind of flip it around, it ends up being the same thing. Right? So if you ever have trouble visualizing that, I mean, ideally you wouldn't do this during a test, but you could just write, what do we have here, 10 less than or equal to x. You're like, okay, I wonder what that's going to be. All right, x is greater than or equal to 10. You know, so please don't hold your test papers up to the light during an actual test, but if there's a way for you to do it at your desk, you can be like, you have your test paper and you just kind of look at it this way, you know? Just kind of try to see right through it.
Can you just like turn it upside down?
You turn it upside down, but you have to have some sort of light source on the other side. Because if you put it directly on your desk, you're not necessarily going to be able to see through unless you have one of those pens or markers that'll do it
Brings
for
a
you.
flashlight to class.
Brings a flashlight and a Sharpie. All right, D.
Equal sign.
We have an equal sign, but fortunately this is already done. There's nothing to do there. Because there is. All right, so I'm going to add 2 to both sides. So that's going to give me a 12. I'm going to divide by 3, which is going to give me a 4. But I'm going to switch it around because I like the x on the left-hand side. So I have x is less than 4 or x equals 4.
So basically just x is less than or equal to 4.
Exactly. That's the same as x is less than or equal to 4. Now let's say you didn't pick up on that. This is what I'm talking about when I say consider. Really think about what you're doing and why you're doing it. If I graph the first part, it would be meh. But then if I graph the other part, true sentence, right?
God.
That would fill the hole.
Wow.
And so you end up with a much simpler way of representing your final answer, just x is less than or equal to 4. Not because I recognize it here, but because I looked at the graph, thought about what that graph represented, and said, oh, wait a minute, that's the same as x is less than or equal to 4. So that's all there is to it.
Oh.
If you add 2 to 4, it does not equal 4.
6.
Wait, I didn't add 2 to 4 though.
Why not?
Well,
That's what we're supposed to do.
you can do it
Oh, yeah, I didn't look at that.
this way. Yeah, you don't want to make it one inequality because if you do that, that's an and situation.
Okay, so you always have to add. Wait,
How do you combine?
I added 2 twice in each inequality.
So
because it was relevant here, because I wanted to get X alone, it was also relevant here. It might have been add 2, add 2, add 3, add 3 if this were different, but it's not. That's wonderful. Not a single thing. I mean, that's a difficult position to be in.
Okay, well, still with this, how do you like, what did you pick any number but 6?
Exactamundo, any number but 6. Which is the same as saying, what?
X is great, no.
A very simple expression that means any number but. Exactly. And graphically, that looks like this.